Shall I start now? Shall I wait like 5 minutes? Hello. Hello, am I audible, everyone? Can I get a thumbs up? Yeah, thank you. Okay. GM everyone, today we'll be going through the track prices at Polygon. Basically, this is a session called Polygon Tracks 101. I have no feedback, so if you're not able to hear, just do a thumbs down so that I get to know. Got it? Yeah. Are you able to hear, guys? This side, yeah. Thanks a lot, everyone. Yeah. So this is a guide on how to build on the Polygon track this year at ETHIndia. So basically what we are trying to do is consolidate all the resources and the GitHub repos that will be useful for you to build on the track. If you refer to our page, there are two important tracks that are there. AIX Crypto, which is basically focusing on on-chain AI agents. And then next we have the ZK track, where we'll be awarding the winners the best DApp, ZK DApp that is hosted on the ZK EVM, Polygon ZK EVM. So during the session now, I'll be guiding you through how an on-chain agent can be built, an on-chain AI agent. For that, I'll be giving you some references and some strategies on how to build. So these are a few things that I've accumulated for you guys. The ChatGPT OpenAI team came up with the new assistant beta feature. So they have the whole page that you can check out, which is the assistant's API quick start. There's an amazing tutorial by one of our devs called Jared, who's making this tutorial. In this tutorial, they'll be teaching you how to build on-chain AI agents. So this will be that you write in a terminal, basically what transaction you want to execute, and that agent will go on for you, will execute that transaction. So for this, you have to use the assistant's API quick start. And first thing, you have to create an assistant. This is all in the OpenAI docs. And then after creating the assistant, one second. After creating the assistant, you have to create a thread and then add a message to the thread and create a run. These are the basic steps of how to like create on-chain like agents, AI agents using the OpenAI Assistants API. That's the basic thing here. We have also a deep dive section provided by them. I'll show you the GitHub repo that is for reference, that you can take for the reference purposes for this, which is an amazing GitHub repo that you'll find useful when you're building for on-chain AI agents. So let me go through the GitHub repo here with you. We have the OpenAI section here. It's taking a little time to load up. So let me give you an overview on basically what it is. As I told you, there are three things. You have to create an assistant, you have to create a message, and you have to then create a thread. So after doing all these things, you will be able to use OpenAI's SDK and then use that to deploy smart contracts and run functions on the smart contracts. So that's how it's going to be useful for you. So due to the internet issues, I'm not able to show you the exact repo right now. But basically what this is there are two sections here. The OpenAI folder consists of all the files that will be useful for building the on-chain AI agent. And then we have the VM. Basically, this is a tool which is used to deploy on Polygon. So the structure here will be to basically build deploy the smart contract on Polygon POS, and then use the OpenAI's Assistant API Quick Starter, and then build an on-chain AI agent. That's what the basic structure will be. All in the Telegram group, I'll be sharing with you all these resources so that you can have a quick look through and build an amazing on-chain AI agent which will be able to do transactions for your sake. So that's one of the things that we are building. To show you some quick references of how amazing on-chain AI agents are being built in the current ecosystem, I have a few like examples which you can check out. You have to definitely follow this account called AI16Z. This is an amazing on-chain AI agent that is trying to beat the A16Z fund. So what this agent does is it executes trades on behalf of on like prompts, and then on behalf of you, and it works 24/7, and it's trying to beat the A16Z fund. It's an amazing Twitter account, and you can check it out for reference on how they have built it as well. This is one of the like success stories that have come out in on-chain AI agents. To show you another example on on-chain AI agents, we have something called AIXBT. So AIXBT is a on-chain agent that is trained on the complete crypto Twitter. So the LLM is completely trained on crypto Twitter, and it is running 24/7 to basically analyze and research on crypto assets that are that need to be invested in. So you can check out the page of AIXBT as well, just as references to see that what great examples are there in the on-chain AI space today. So this is one example. AI16Z is an example. So how do you build these crypto on-chain AI agents? I showed you an example. You can use the OpenAI Assistants API toolkit. If that is, if you wanna use something else, there's another thing that you can use. It is called Brian AI. So it's something called Ask Brian. So you can use Brian AI basically. So you can see here, you can send transactions through prompt. You can deploy smart contracts to prompt. So this is one of the examples that has been built and deployed on the Polygon POS network. So this tweet just demonstrates that how the Brian AI is deployed on Polygon POS. And what basically Brian AI does is through prompts, you can execute smart contract transactions there. So let's go back to what we expect from the people who are building on Polygon Track. The thing we are expecting, and the most important thing we have mentioned, is develop an AI agent to bridge assets across chains connected to Aglia using the unified bridge. That's one of the main things we want. So let's slow down a little bit here. These were examples of like basics on-chain AI agents. But when you want to build specifically on Polygon, if you want more points and if you want to win the track prizes and want to make like great projects which will be useful in the future, you have to definitely know some about Aglia. Aglia is this new framework that is come up by Polygon, which is going to aggregate all the L2s and L1 into one and create a seamless experience for the user. So basically what Aglia does is this amazing diagram here. So all these chains on top are the L2 chains. They are connected using the aggregation layer, and then they are connected to the unified bridge contract. Aglia is making it easy for users to initiate cross-chain transactions. And this is through something called a unified bridge contract, which is on Ethereum. We have a great tutorial on the unified bridge by one of our DevRel engineers called Brian, and I'll be sharing the repository and the YouTube video of Brian as well. So that will be amazing for you to see, and then you can use that as a reference on how to build. So as I said before, if you want to build normal simple on-chain AI agents, that's good. But if you want to build something specific for Polygon, because Aglia is a new thing in Polygon, you can build the on-chain AI agents, ask them to do transactions cross-chain. So I will ask from chain A to chain B, I want to send a token using the unified bridge contract, and using the on-chain AI agent, make a front-end framework just by prompting it that I want to transfer this amount of USDT from this chain to that chain. It should be able to execute an on-chain cross-chain transaction. That's going to add a lot of value to your project from Polygon's perspective, because Aglia is the big thing that Polygon is betting on. And if you'll be the one of the first people to make a project on the unified bridge. So that will be amazing if you guys can pull that out in 2 nights, but it is a little hard. So just make sure that you need any help, come check us out at the booth and stuff like that. We'll be there to help you. for the unified bridge, because it's a particularly new thing, there's a whole repository called unified bridge and bridge and call, which is written by one of our DevRel engineers called Brian. It's an amazing repository which goes through everything you need on how to understand the unified bridge first of all, and how to build on the unified bridge. So I gave you a couple of examples of on-chain AI agents. So an amazing project will be using these agents to execute cross-chain transactions on the unified bridge. You can go through this entire actually this first part is just explaining what the unified bridge is, how it works, which is not needed for DApp level developers. It's more of a protocol level thing. But then when you go down, if you go to this part, is code walkthrough and how do we use the unified bridge, asset bridging and these kind of stuff, and references. You can see exact repositories and code that will be useful for you to develop the unified bridge smart contract. So again, I'll be sharing in all the references on GitHub for you guys so that you can look at it and build on the Polygon track. That will be great. So we covered, are there any like questions on the CryptoX AI on-chain agent part? Have you guys like understood? Can I get a thumbs up if you guys are following through? Like a thumbs up from everyone. Great, thank you. So I would like to sum up and give us a quick summary. On-chain AI agents, you can use OpenAI's SDK. You can use Brian AI. That's also an SDK. There's another thing called Goat AI. You can check them out as well. It's also a software development kit used for building on-chain AI agents. These three are pretty good. That's why I'm recommending them to you guys. And then you can use the unified bridge and do the cross-chain transactions. So CryptoX AI part track is done for now. So again, like this is one of the major things that's happening in crypto. So this is one of the track that Polygon has introduced. And another disclaimer and thing to be noted, that these dApps for CryptoX AI should be deployed on the Polygon POS network. There are two networks in Polygon, Polygon POS and Polygon zkVM. zkVM will be mostly focused on extremely security kind of DeFi applications, but on-chain AI agents for now, you can deploy it on Polygon POS. That will be great. And for the ZK track, we need people to deploy on Polygon zkVM. So that's basically the structure we are following. Okay, so this part completes our CryptoX AI. There's another track called the ZK track. As you guys know, that Polygon has one of the best ZK teams out there. Polygon ZK team is currently developed a framework called Plonky 3. It's an amazing framework, one of the most fastest provers for zero knowledge, and it's modular as well. So you guys can check that out, Plonky 3 as well. So let's go back and see what we expect from the ZK EVM and track as well. So we need you guys to create amazing ZK related products and dApps, and the resources you can use for these are the Plonky 3 that I first told you. Plonky 3 is developed by Polygon, is an amazing framework and a toolkit for you to use. There's this tutorial by Brian, which explains the Plonky 3 Fibonacci example, where we go through how do you exactly make constraints in Plonky 3. It's a huge process, and you can understand it to make great apps on Plonky 3. So I'm just showing this to you, but it'll take some time to understand this. So we have like a day or so, 2 days for building. So you can go through this entire repository and check out what exactly you need or to make constraints using the Plonky 3 framework. That will be great. And then to point out another thing, there was Plonky 2 before, which was the fastest proving recursion ZK framework. But then we have Plonky 3 now. The major difference between these two frameworks is Plonky 3 is modular framework. It means that you can switch two important things that are in ZK. That is a hash and a field. So currently Plonky 3 now supports these fields and these hashes. So why do we need to do a combination of fields and hashes? Basically depends on what you're trying to do with your ZK circuit. If you want a smaller proof size, if you want faster proving time, you need to alternate, and what kind of a ZK circuit you have. So you can switch and swap between fields and hashes and get the best efficient ZK circuit there. So that's one of the examples for Plonky 3. Also, something you can use for developing on the ZK EVM track that we have is SP1. Okay, so to go through what SP1 is, SP1 is a ZK VM, or something we call a ZK virtual machine. A ZK virtual machine is something which allows us to write normal code and then converts that code into a ZK proof. So the process of writing a ZK circuit is extremely tedious, and people who have gone through it will understand it's not easy. So what Succinct, which has partnered up with Polygon Labs, has done is made it very easy for people to develop ZK. Succinct's new SP1 is the most user-friendly ZK VM is out there, and through that you can write code in Rust, and then you can convert it into a zero knowledge proof. That's what Succinct's ZK VM is doing, called SP1. You can use this framework as well to build ZK dApps on Polygon on this track. So Plonky 3, we covered ZK VM called SP1. These are the old, the whole ZK, the docs for SP1. They're completely very detailed and will help you go through how to set up SP1 packages and how to run ZK circuits there. So this is the most amazing thing out there. You can check this out as well. So after this, we will go through another thing called pessimistic proof. This is also an example, just repository I'm showing. It's something Polygon is developing for the security of the AG layer. It is completely written on ZK VM SP1. So this is one of the examples that we can give you of how to use SP1's ZK VM. Yeah. So after this, we have covered the ZK track. Basically, what we want you to do is, let's just go back and see one of the things that we have done. So there are 3 things you can use now. Plonky 3, we can use SP1, and we can use these 2 things for building our proofs. And we are also like encouraging you to build identity dApps. So how do you build identity dApps? There is something called 2 references given here called Privado and an Aadhaar. There are 2 private identity things that we can use, and we can use these to build proof systems for identity as well. These are also promoted during our track, and someone who's using an Aadhaar and Privado will also be given an opportunity to win the ZK VVM track. So to sum up, finally, what I'm trying to tell here is you need to put these ZK dApps on this Polygon ZK EVM chain. So the CryptoX AI, the agents go on the Polygon POS chain, and the ZK dApps go on the Polygon ZK EVM chain. They're 2 separate things, and hackers need to keep in mind of the distinction that we are giving here. Okay. So I've summed up my complete session here. I would like to take any, are you guys clear with the stuff I've given out? Can you give a thumbs up or something like that so that I can understand? Yeah. Thanks a lot, guys. So 2 tracks, mainly CryptoX AI and ZK track. We'll be present 24/7 in the Polygon booth for any doubts and queries. We are taking doubts now, so if there are any doubts, can you please ask? Are there any questions on something that you want to ask, you're not understanding in the Polygon track, or you're facing any difficulty in understanding? Is there something like that? Okay, I'm there for another 2 minutes, then my session's ending. So basically, build the best dApp, guys, and if there's an actual real world use case, you'll be getting the Polygon track. Yeah. Thanks a lot. I'll conclude my session. Yeah.